Hey there, it's me. I have some thoughts on Twilight fan fiction, but before we get to that, I want to talk about making sounds with Python. It's pretty easy. You just need NumPy and SciPy basically. And before we actually go and make the sound, let's get a bit philosophical and see how actually sounds are created. Sounds are just continuous, like regular waves that move through a medium, and right now I'm talking through air, which is a medium. And waves can actually be just represented as like these oscillations that change in amplitude, which is like how loud it is, and also frequency, which is like the pitch. And a very beautiful thing about digital audio is that we can actually just programmatically create these waveforms. uh, so this is how it kind of is like. So you have these particles in the air, and as you have the sound, the particles just get excited and they form these waves. I mean, it's not always as smooth as a sine wave, but it is a combination of some sine waves, and it reaches your ears. And we can actually like treat these particles. I mean, imagine this is air and these are particles in the air, and you just like excite them to actually like create this. So we just need to go from particles to like a wave. A very cool way that we can actually visualize this is by using a circle and just like going around the circle, and just like depending on like how much the height is, you can actually like control the amplitude, and also like how much you move the angle kind of controls the frequency, which is pretty cool. So, and also the number of points here that are actually like creating these sine waves is the sample rate. And now we just saw how we can define our frequency, we saw our amplitude, and we can just set our duration. So duration is set by like our line space. So this line is like goes on for how, depends on like how many samples we are using and how long do you want it to go. So right now we wanted to go for like 4 seconds. And we can actually like calculate the angular frequency by just multiplying like 2 pi with the frequency, because we are going from a circle. And now that we know how to calculate like the angle to move it like a sine wave, this actually gives us the phase, and we just like multiply the phase, like the sine of the phase, by the amplitude, and it gives us a smooth little sine wave. Kind of sounds like this. And we can actually create phase from frequency using this like simple formula, and we can visualize our nice smooth little sine wave. And sine wave is actually called fundamental because you can actually create complex waveforms by just combining sine waves with different frequency and amplitude. And it's pretty cool, all the shit that you can do with it. And this is just like a simple waveform. We can also have more complex waveforms which move away from like the smoothness and gives us like some buzzy textures. So here are some examples. We have square wave, which looks like a square. We have a triangle, and we also have our sawtooth wave, and this is how they sound like. Oops, that was loud. And there's triangle, and then there's sawtooth. Yes, and it's pretty cool how you can actually use the same circle example, but just like look at phase going from like -1 to 1 and model like your sawtooth wave. Uh, so now that we know how to create waveforms, we can actually stack those waveforms to like create sequences. So now we have these multiple tones playing at different frequencies, and I can just like stack them together and have some sort of, I don't know, melody. So it's a bass line, I guess. Hard. I could put a breakbeat to it maybe. It's pretty cool what you can do by just stacking different frequencies. And this is all just like happening in Python. And I can also do some interesting stuff with these waveforms. So I just take like a square wave and maybe I give it like 3 as the frequency, just like pretty low. And this is how it looks like. I can actually make it sound, it kind of sounds like a kick, and you could actually just add some filters and like cut off some frequencies, and it could sound like a crisp nice kick. It's pretty nice. And I mean, this is not the only thing that you can do with it, like stacking them or like playing with the frequencies. You can actually do some like arithmetic operations. And before we do that, let's make a simple oscillator. Now that we know how to make these waveforms, we can just like use this method that we already know, kind of creates phase from the frequency, and then we can use that to create our sine wave. We can use that to create our triangle, our square wave, and our sawtooth wave. Now that we know how to create these waveforms, we just create our oscillator class that like takes these waveforms and just like plays the waveforms given the frequency and like the duration. So we can just have a sawtooth oscillator defined, let's say play 100 hertz for maybe like one amplitude and zero point 0.5 duration is like the number of seconds, and you can just create an oscillator. And you can also have multiple oscillators, and I can just like add them. And this is just now a combined sine plus sawtooth wave. As you can see, it's just like added together. And I can also change how it looks like by like updating the frequency. Let's say now the sawtooth wave is like 1000 hertz. So now you're going to have like more sawtooth features. And if I reduce this and I increase this to 1000, then it's going to look more like a sine wave with like really less sawtoothy elements. And this is how it kind of sounds like. I'm going to again decrease the volume. Pretty cool. It's like combination of both, and this is just like linear combination where I'm adding up two waveforms, and that's necessarily not what you should do because that's boring. First of all, uh, so I generally give this talk as like a tutorial, which I've done at PyCons before. So this is now up to you to like combine these waveforms and create interesting sounds and interesting effects. Is pretty interesting. And the notebook, I'm going to attach the link on like the description. You're going to have all of this. But I want to show you some pretty interesting non-linear operations that you can do, which actually create new frequencies in the waveform that weren't really present in the original signal. And this kind of tangentially takes us to the next part, which is modulation. So let's say that you want to take a modulo of the sine wave and the sawtooth wave. You actually have this very interesting bit crushing sound. Yeah, it sounds like this because there is some kind of aliasing happening. And if you're wondering what is aliasing, it kind of comes back to the sample rates that we are using. So we have these points that we model to make like a sine wave, and now this kind of looks like a sine wave because you have enough number of points. But what if you don't have enough number of points? Then you have to kind of make do and like create something that kind of looks like a sine wave but does not really capture the whole shape. This is actually looking pretty good. Maybe I remove more points. Yeah, so when you have to like kind of make do with these things, then your shape gets a bit weird and your sound sounds a bit rough. And this is what is a very short definition of aliasing. It is a lot of things. uh, but we can get pretty interesting sounds out of it, and you can also multiply the two sounds and get some interesting like distortion effects. Yeah, wobbling. And this is actually something that's called ring modulation or like amplitude modulation, depending on like the frequencies that we actually like multiply. And some things that I have been looking to try out is like trigonometric functions. You could use like sine wave, like just wrap it around like more trigonometric functions like cos, and use like exponentials, logarithms. You can go polynomials and or keep it simple, do min max, but you can get pretty interesting sounds with this. So yeah, pretty basic. You can just like import these libraries and just start making sounds with Python. uh, Now that we have it, we're going to move on to the next part. It's pretty fun. It's how we modulate these waveforms. See you then. Bye.